So we will discuss linked hash set now. Okay, for that we will create a new class. Let's say, you can say set demo 2 or you can say linked hash set demo also. Set demo 2. Okay, finish. And here also we will be creating the set reference and class object. So we will say set s is equal to new linked hash set. Okay, we will import the classes from java.util. So we will say import. After this, again we will add some elements into this collection. So I will say add. See, the code will be same as your hash set code was there, only output will be different. Okay, and methods also almost same. So let's say we will add here 20, plus we can add some long value also. Let's say 12 is this L means long value. We can add a double value also. Okay, and then we can add a string also. Okay, now we will print it. Same, remove and all methods, add all methods, they will work same. Okay, and if you run it, you say it will give you output in the insertion order. It will maintain the insertion order. Now again question is, can we have duplicates here? See, it is also a set only. It is not a list. Okay. So even though you are getting the output according to the insertion order, but still it will not allow duplicates. I mean, you can write it syntactically, it will not give you any error, but in the output you will get it only once. Okay, so that is what is linked hash set. Okay, again the other methods will remain same. If you see here, it is also a child of set interface only, so it has all the methods which are there in your hash set, only the output is different, that's it. So now what TreeSet does, okay, other methods you can try with this by your own. We will see here quickly TreeSet also. See, if you want, you can create a separate class for TreeSet. I will just write it here only. TreeSet. See, you can use class reference also, you can use interface reference also, not a problem. So let's say here I am writing set s1 is equal to new TreeSet. Okay, so these are three classes which are mostly used with set: hash set, linked hash set, and TreeSet. TreeSet will do what? TreeSet will give you output in a sorted way. And but with TreeSet, what is the limitation? That at a time you can add one type of data, otherwise it will get confused, like how to sort the data. If you are giving integers also and string also, it will get confused. So that's why here you will add similar type of data. Let's say I'm giving 30 here. See, it's better to work like this. Okay, like here we will take a generic type, and let's say here I will say integer, means I'm dealing with integer only right now. This is known as generic type. It is used mostly for type safety, because when we deal with multiple class types, see, in collection everything is a class type, there is no primitive type. Okay, whatever objects you are giving in, even if they are primitive type, internally they are getting converted into their wrapper class type. So sometimes it is the chances are high that you will get class cast exception. Okay, so that is why to overcome that we use these generic types. Okay, generic type means at a time we work with one class type. Okay, and in tree set, this is the thing that at a time you will work with one class type only, because it will give you the output in a sorted way. So it will sort them according to a particular type. So let's say I am adding it. Now you must be thinking, then what is the benefit of using collection, when here also we are dealing with one type only. But the answer is, here you can do many extra things which you cannot do in array. You can increase or decrease size at runtime, and this is more flexible. You can handle a big amount of data with collections. Okay, so these are the benefits. Type safety is there. Okay, so mainly even if we are dealing with collection, we deal with one type of data at a time, and it can be a primitive type, inbuilt class type also. It can be a user defined class type also. Okay, so how to deal with that user defined class type, that we will see in the upcoming sessions. Okay, so let's say I am adding one more integer here. Let's say add 5. Okay, and just simply print it. Okay, and if you see here, you are getting the output as sorted order. Okay, you have inserted 30, 20, 10, 5, but you are getting 5, 10, 20, 30. It is not a reverse, it is not reversing anything. Let's say I am putting this 5 in between here. What happened? Okay, I want to put this 5. See, can we have duplicates in tree set? Again, the answer is no. If you will write syntactically, it is not an error, but in the output, it will come only once. Okay, so if you can see again the same output 5, 10, 20, 30. So it will give you output in a sorted way. So if instead of integer we are working with string, again it will sort it according to the alphabetical order. Okay, ASCII value of alphabets it will sort. So that you can try by your own. Rest of the methods like add all, contains, is empty, size, everything will work similar to your hash set. Now one more method is there in set, which is very important. Remove is there. We have already seen remove. One more method is there, which is s1 dot clear. Okay, now what this method does, see, if I will print s1 once again, what it will do, see, you are getting an empty set. Okay, so clear will do what? It will clear the entire collection. See, there is a difference between remove all and clear, and it is asked many times in the interviews and in the exams. Okay, remove means you will remove a particular element. Remove all means you will remove a particular collection. But clear means it will clear the entire collection. So be careful with this. It is also a very important and useful method, used many times if you want to clear the entire collection. So we have discussed all the basic functions which are there in set interface with basic classes which are HashSet, LinkedHashSet and TreeSet.